There are lots of ways to take advantage of RealFlow nodes when dealing with Hybrido. If you're still not familiar with Hybrido, let me bring back the RealFlow community page, and another of my favorites places here is Luis Miguel Mora's RealFlow blog. This is the best point to get started with Hybrido. If you are still not familiar with it, you have a lot of cool stuff with the Hybrido workflow, demos, a lot of scenes to deal with, and it's really amazing, and I will recommend you to take a look at it if you want to get familiar with Hybrido. Okay. As I told you before, there are a lot of different ways to take advantage of RealFlow nodes. For instance, once we have, I have this this simulation that it's pretty low resolution, but just for speed up the demo. Once you have simulated the grid fluid domain, you can create different areas or different volumes to get much more resolution, to get splashes, foam, mist, etc. So for instance, in this case, we can set these boxes here and we will get splashes such as in this preview. Okay, so as we know, we can set different IDOCs and send each one of these elements, insert each one of these elements to an IDOC. Once we have different IDOCs, we can determine if we are going to set, if we are going to simulate this IDOC separately, sending it to the job manager, sending it to the network via job manager, or assigning directly the task, okay, adding a new job, and as we know, setting up the file path IDOC name that we want to simulate, and if we want to assign any dedicated machine. But also, and especially for high complexity scenes, we have the ability of splitting up this scene into into an important number of IDOCs. For instance, in this case, I'm going to split up the grid fluid domain area into 27 IDOCs. Here we have them. And with these two buttons here, it will be pretty easier for me to manage actually all of the 27 IDOCs. It's not necessary that I go one by one inserting the different elements. For instance, taking into account some of the elements, maybe sharing actually different IDOCs. So we have this button right here, update, that automatically is going to detect every single element in the scene that is intersecting in the IDOC volume. So automatically RealFlow is going to insert in each one of these 27 IDOCs the elements that are intersecting in its respective volume. Once we have the IDOCs updated with the different elements, geometry that we have in the scene, we are able to create secondaries per IDOC. For instance, in this case, we are going to create one single splash per IDOC. Therefore, if we take a look right now at each one of these IDOCs, every single IDOC is going to have its own splash. In this case, the splash is going to be exactly the same size in volume as the IDOC itself. Okay, next step is to make things faster and easier for us, we're going to group these splashes, and we are going to rename it. And obviously we're going to link these splashes to the grid fluid domain. At this time, I'll be able to add each one of the elements that I want to interact with these splashes, such as gravity or the 3 pieces here and the floor and walls, to the splashes in one single action, in one single click. And now, if I select all of the iDocs and send them to the job manager, RealFlow is going to automatically send all of the tasks, all of the 27 iDocs, and it's going to queue all of them. If we take a look at the project folder, here we have the temporary files that RealFlow is creating. And if we take a look at the particles folder, here we have the different bin files that are being developed with the simulation of the 27 iDocs. Another element suitable to use different nodes is the surface. This element will generate a distance field, and it's crucial in the creation of secondaries and the grid mesh. If there's no surface computation, we will not get secondaries at all. We have 2 options to set as the source of the surface. Summarizing, let's say, in one hand from field, this one is the fastest option, and it's interesting for distance views. And from particles is the most accurate option, suitable for close-ups or if you want to get much more detail, but takes more time. Each one of these parameters here have its own impact on the different secondaries, but in this video we will only take a look at the different methods of creation and how to connect them with RealFlow nodes. On request is a default option, and basically means that RealFlow will calculate the distance field if secondaries or a grid mesh are present in the scene setup. Otherwise, if, like my case, none of these elements, no splashes, no foam, no secondaries or no grid mesh are present in the scene setup and present and active in the scene setup, RealFlow will skip the computation of the data of the distance field in this case. Always is going to force RealFlow to generate the data even though no secondaries are present in the scene. RealFlow will generate the data, the distance field in this case. Never will disconnect the computation data, never is going to skip the task, is going to do nothing actually. Even though we have lots of secondaries here, with this option, with this method, none of this data will be calculated. And finally, we have the cache option. If we have previously calculated this data, we can use it in cache mode. Instead of calculate it again, we will read it from disk. Okay, let me disconnect these elements here and we'll make a test with some different options. Let's begin with on request with the default option. Let's open a project folder. And here is where the surface data is going to be stored. let's open the distance field. And in this case, we have on request, but we have no secondaries. We have no grid mesh here in the scene setup. So RealFlow is going to skip, actually is going to save a 1 kilobyte file per frame, is going to skip the task of the distance field computation in this case. Let me stop it, and we'll see the difference if we insert a secondary here. Let's remove these files. And if we set a secondary with the same option, with on request, RealFlow will identify one secondary is present and active in the scene and will generate its respective distance field in this case. At this point, we can realize that not too much particles are actually being created. That's a very, very low number of particles, but we can realize that the generation of the distance field is taking an important part in time in the computation, in the calculation of the whole process. And here, with this computation, is where we are going to take advantage of nodes. Okay, let's reset and let's delete these files here. If I remove this element and set always, as we know, RealFlow, even though we have no splash here, RealFlow is going to create the distance field. Again, you can realize that the computation of the distance field, it takes an important part in time. In the other hand, if let's delete this. Set it to never. RealFlow is doing nothing with the distance field in this case, but we can realize that the grid simulation is way faster. No computation, no distance field computation is present, and therefore the grid domain in this case is being way faster. Okay, let's reset. So to calculate the surface data takes an important part in the time of the computation process. Therefore, creating this data, creating this surface data here, at the same time as I'm creating the grid, or with always, for instance, or creating this data at the same time as I'm simulating the secondaries with on request, definitely it doesn't make sense if we can derive this task, if we can assign this task to RealFlow nodes, if we can take advantage of RealFlow nodes to assume this particular task. Consequently, we can take this into account, and for instance, if I'm going to simulate the grid fluid domain for first time or from scratch, I can set all of these different parameters to never. Therefore, the grid fluid domain simulation is going to be way faster. And once the grid has been simulated, if I just simply cache the grid, okay, it's being read from disk, I can split up the timeline into virtual ranges of frame and calculate this surface with the always option, for instance, for this distance field option, and send this task to different nodes. Each one of my nodes are going to assume one different range of frames. For instance, we can set here that my FLW file is going to be calculated in one determinate machine, and I'm going to define here if I want to assume this first range, this second range of frames, or this last range of frames. Once the surface data has been created, has been calculated, I can use cache and I can create my secondaries. Or if my secondaries were already done, I just can to set them actives. And with this last point, I'm going to finish this video. I hope it's helpful for all of you who had no previous contact with RealFlow nodes, and hopefully we'll be back soon with more training stuff and more features using RealFlow. So thank you very much for watching, and see you soon.